This is from the Chapter 3 Extra Practice Packet, page 4, number 2. So a company produces 2 models of calculators at 2 different plants. And one plant A can produce 60 of Model 1 and 70 of Model 2. And one day, Plant B can produce 80 of Model 1 and 40 of Model 2. The company needs to produce at least 460 of Model 1 and 430 of Model 2. Find the minimum cost. Assume it costs $1,200 per day to operate Plant A and $900 for Plant B. Now, when I was prepping this question to explain to you how to do this problem, I didn't know where to set up my variables. And just remember that to set up your variables, figure out what I'm trying to do. I'm trying to minimize cost. So cost for one thing is $1,200 for Plant A and $900 for Plant B. So that tells you what your variables are. And that's days at Plant A, and Y is days at Plant B. Now, okay, this is why this is confusing, because you have Model 1 and Model 2 in Plant A and Plant B, and I don't know which one is which. So that's why I set up that cost, the minimum cost function first, so that I could figure out, okay, $1,200 for one day, per day for one thing, $900 per day for the other, quote, thing. So that tells me that Plant A and Plant B are going to be my two variables. Now we have to write a restriction equation for Model 1 and a restriction equation for Model 2. Okay, so Model 1. So Model 1, Plant A can produce 60 of Model 1. So 60 times Model 1, times Plant A, and then, so you have to go to Plant B. So Plant B can produce 80 of Model 2, and I need at least, so this has to be greater than or equal to, but I forgot my Y. This has to be greater than or equal to 460, because we need at least 460. Now the other one, Model 2. So Model 2, Plant A can do 70 of Model 2. So 70 times the number of days. Okay, and then Plant B can do 40 of Model 2. And 430, greater than or equal to 430. Okay, now again you have to trust me. Graph by using intercepts, so make your intercept chart for each one of these. The graph doesn't have to be perfect, it just gives us an idea of what the graph looks like when we graph it on our calculator. So our first intercepts are this, and then the intercepts for our other one are, and 6.14. Okay, so that was all the calculator work that I did. It's kind of boring calculator work. I'm not going to show you that. So I'm going to go by units of 1, and I'm going to go up to maybe 11. So you don't have to mark what each one is, as long as you break out what your scale is. Okay, so our red equation, you're just approximating these. 5.75 and 7, 5, 6, 7 connect using your straight edge. Trust me, I'm not using a straight edge. I'm being a bad math teacher. Y-intercept is almost 11. The other intercept is a little bit more than 6. Now shading. Again, testing the point 0, 0. When I test the point 0, 0 in this first red equation, that makes it false, so I'm shading above. And even for the blue equation, I'm also shading above. So I'm shading an unbounded region. So keep that in mind. What we're going to be plugging in is that point right there. I would round up, since you're shading unbounded and greater than, I would plug in this number that is greater. So I would plug in 8, 0. I would plug in this point up here. I would plug in 0, 11. And we need to find this intersection point. So, again, solving this equation for y. I get 80y is equal to, I just changed the inequality sign to an equal sign. It's not the end of the world. And then divide by 80. And then I type this into my calculator like this with the parentheses around the whole numerator. That tells my calculator 6D. Now here, I do 430 minus 70x, and then I divide by 40. So we have our other equation. And again, this is how you're going to type them into your calculator. So bringing up the calculator. These are what we have. I'm going to press graph. I've already adjusted my window. Let me show you what the window was real quick. I meant to show you that before. I've adjusted my window to something very similar to how I graphed it on my paper. So I have my window, I press graph. I don't have the shading, but all I need to do is find this intersection point. So again, second calc, number 5, intersection. Now this doesn't matter. Honestly, this doesn't matter because you only have 2 curves. First curve, press enter. Second curve, press enter. Guess, doesn't matter. So our intersection is 5, 2. So this point right there is the point 5, 2. So in our cost function, we are going to plug in 0, 11, 8, 0, and 5, 2, and figure out which one gives us the minimum cost. So when I plug in 0, 11, showing me the actual plugging in, okay, we get 9,600, and then 1,200 times by 5 plus 900 times by 2, and that gets me 7,800. So go back to the problem. What are we looking for? Find the minimum cost. So I'm looking for the smallest value. My smallest value here is there. So, just erasing so I have some room to write, we have a min cost of $7,800 with plant A for 5 days, running plant A for 5 days, and plant B for, what was my answer? 2 days. And that's how you do that example.